let's do an example. Okay, so let's say that I had a Schottky diode. So I'll have a metal, and let's say the metal is tungsten. And I have a semiconductor. Let's say the semiconductor is N-type silicon. And I will dope that silicon with a doping concentration of 10 to the 16th donors per cubic centimeter. If I were to calculate the built-in potential in this junction, and this is a typical value for a Schottky diode, that potential barrier will be 0.3 volts. Use the equation on this slide to calculate what the depletion region width is. That comes out to 0.2 of a micron. And if we use the electric field equation on this slide, the magnitude of the maximum electric field is 3 times 10 to the 4th volts per centimeter. So that gives you an idea. You can see that the potential barrier, which is the turn-on voltage, is lower than for a silicon PN junction. The depletion region width is a little bit narrower as well. Okay, and now I'd just like to leave you with a couple of questions. So in all these videos, I haven't talked about what the units are of the work function, and I haven't talked about the units of the electron affinity. And there's some tables in your book that you can use to look up electron affinities and work functions for different materials. These are tables 9.1 and 9.2 on page 333 of the textbook. Unfortunately, that table doesn't tell you the units either, but I'm sure based upon what kind of barrier it is, and by looking at the energy band diagram, you can figure out what the units are for these for the work function and electron affinity.